The cold waters of the Stockholm archipelago hide a defensive line that has not fired a shot in 3 centuries. Below the surface of the Vaxholm Strait, the seabed is a graveyard of wooden giants deliberately sunk to create an impassable wall against enemy fleets. For decades, marine archaeologists knew the roster of these lost sentinels. They knew the names of the ships sacrificed to block the channel. But one name on the list carried a weight that the others did not. It was a ghost that had haunted the archives since 1629, a ship built to correct the most famous naval engineering disaster in Swedish history. The Vasa is the prize of the surface world, a resurrected icon of imperial ambition. But the Vasa had a sister, a twin built by the same hands in the same yard, using timber from the same forests. Her name was Äpplet, or the apple. While the Vasa sank minutes into her maiden voyage, the Äpplet vanished into the obscurity of history. The archives stated she was scuttled in 1659, somewhere in this narrow traffic channel. But for 360 years, the exact location of the sister ship remained a void in the map. She was the missing half of the equation, a rare control sample that could help tell us whether the fatal flaw of the Vasa was a one-off accident or a symptom of deeper problems in the Royal Shipyard. In 2019, the search team from the Museum of Wrecks believed they had closed the file. Their side-scan sonar painted 2 massive wooden signatures on the channel floor. The dimensions suggested large warships. The location matched the 17th century blockade charts. The excitement was immediate and logical. One of these must be the Äpplet. The team dived the sites, measuring the oak timbers and the framing. They brought back data that shattered the hypothesis. These were not the sister, and they were the Apollo and the Maria, medium-sized ships from a later generation, likely 1648. The Äpplet had refused to be found. The channel was crowded with wrecks, but the giant was still missing. The failure of 2019 forced a recalibration. The strait is a hostile environment for survey. It is a choke point for modern ferries and cruise ships, churning the water into a dark, turbulent haze. The bottom is a chaotic mix of mud, stone, and centuries of debris. To find a specific wooden hull in this pile of intentional garbage requires more than luck. It requires a forensic grid search. In December of 2021, the team returned to the water. They pushed the survey zone further into a sector that had been dismissed as unlikely. The sonar return that scrolled across the screen was different. It did not show the broken, scattered remains typical of the smaller blockships. It showed a massive, coherent structure, a hull that extended for nearly 150 feet. The signal suggested a ship of the line, not a converted merchant vessel. The archaeologists dropped into the freezing current to verify the target. As they descended, the murky water gave way to the solid, dark walls of a hull that stood nearly 20 feet off the bottom. This was not a fragment. This was a fortress. The divers drifted along the port side, counting the gun ports. They found 2 distinct rows of cannon openings. And this was the first critical filter. The Apollo and the Maria were smaller, single-decked ships. A double-decked warship in this specific location narrowed the candidates to a single handful of capital ships from the Great Power era. But size alone is not proof. The sea distorts scale, and the archives are full of large ships that met their end in these waters. To claim this wreck as the missing sister, the team needed more than a silhouette. They needed a fingerprint, and the wood itself would have to speak. The divers identified a section of the hull where the oak planking was exposed. With a specialized coring tool, they drilled into the hard timber, extracting a cylinder of wood no larger than a finger. This sample contained the atmospheric history of the 17th century. It held the pattern of rainy springs and dry summers that the tree had absorbed while it was alive. If those rings aligned with the same regional chronology as the Vasa, it would become a decisive line of evidence, alongside the hull's form, construction details, and the archival record. But if the wood dated to a later decade, this would be just another anonymous casualty of the blockade. The team surfaced with the sample, leaving the giant in the dark, waiting for the laboratory to deliver the verdict. The geometry of a warship is a set of compromises written in oak. Every foot of width adds stability but subtracts speed. Every extra gun adds firepower, but raises the center of gravity. When the survey team descended to the massive hull on the seabed, They were not looking for treasure. They were looking for a specific mistake in the math. The wreck lay listing to starboard. Its upper works collapsed into a chaotic debris field, but the lower hull remained intact up to the lower gun deck. The distinctive shape of the tumblehome, where the sides of the ship curve inward as they rise, was still visible despite centuries of decay. To identify this vessel as the sister ship, the divers had to measure the beam at its widest point. This was the critical variable. The Vasa had been unstable because she was too narrow for her height. Her sister, launched 1 year later in 1629, was the correction. The builders had widened the hull by approximately 4 feet to fix the fatal flaw. If the tape measure on the seabed read 38 feet, this was just another unstable failure like the Vasa. If it read 41 feet or more, it was the engineered solution. Modern naval architecture explains this correction with a concept called metacentric height. A ship is a pendulum that must return to center. The weight of the guns and the hull pulls down through the center of gravity. The water pushing up against the hull creates the center of buoyancy. When a ship heels over in the wind, the center of buoyancy must shift far enough to the side to create a lever arm that pushes the ship back upright. If the hull is too narrow, the buoyancy cannot shift far enough to counteract the weight of the guns. The lever arm is too short. The ship simply continues to roll until water pours into the gun ports. The Vasa went down because her righting moment was razor thin. Her builders understood the danger in practical terms, even if the later mathematics had not yet arrived. For the sister ship, the fix was to change the proportions so buoyancy could swing farther under a heel and push back hard. Down on the seabed, that invisible correction would show up as a single, unforgiving number. On the bottom of the Vaxholm Strait, the divers stretched their measuring tapes across the widest part of the frame. The visibility was poor, often less than 3 feet, forcing them to work by touch as much as by sight. They recorded the numbers on their slates. The beam measured 41 feet. This was the exact dimension of the corrected design. The hull was significantly wider than the Vasa, yet it retained the archaic framing style of the early 17th century. As they moved aft, the team found another structural anomaly that separated the ship from the later vessels of the 1640s. In the stern, the hull flared out to accommodate a large cabin structure. Here, they noticed an extra gun port in the aft quarters on the upper gun deck, an unusual detail that hints at experimentation with rear-facing firepower and opens new questions about how the stern was arranged. The hull form was persuasive: the beam, the double gun decks, the odd extra port in the stern quarters. But underwater, even clean measurements can lie. Timbers swell, fastenings fail, and a frame can creep outward under centuries of silt. That is why the core sample mattered. Geometry could point to Äpplet. Only the tree rings could seal it. In oak, time is written in rings. If the pattern matched Vasa's world, the wreck would have a name. The divers returned to the massive hull in the Vaxholm Strait with a specific mission. They needed to extract this calendar without damaging the ship. Using an increment borer, a tool that looks like a hollow corkscrew, they targeted the heavy framing timbers near the keel. The device twists into the dense, waterlogged oak. They're cutting a sample the diameter of a pencil. When extracted, this core reveals the cross-section of the tree's life. It is a delicate operation. The wood has been submerged for nearly 400 years. It is soft on the surface, but retains its iron-hard core deep inside. The samples traveled from the seabed to the laboratory in Stockholm. Here, the science of dendrochronology takes over. Analysts place the wood cores under microscopes, measuring the width of each ring to the nearest hundredth of a millimeter. They plot these measurements on a graph, creating a jagged curve of peaks and valleys. This curve is then slid against a master chronology, a database of tree growth patterns for Northern Europe that covers thousands of years. It is a statistical matching game. There's only one position where the unique fingerprint of the sample will align perfectly with the master record. When the results for the Vaxholm giant appeared on the screen, the match was absolute. The growth rings aligned with the master chronology for oak trees grown in the Mälardalen Valley, just west of Stockholm. The outermost preserved rings dated the felling of the timber to 1627. This was the smoking gun. 1627 matters because it sits in the shipyard's most frantic consumption phase, when the crown was feeding whole forests into a Baltic fleet. The Vasa's timbers came from the same Mälardalen supply, cut just a year or two earlier. This Rex oak was felled immediately after in the same royal pipeline that kept the yard building at full speed. This biological timestamp eliminated all other candidates. The Apollo and the Maria belonged to a later generation built with different timber and different priorities. A felling date in 1627 fits a ship completed in 1629, and when the shock of the Vasa disaster was still fresh in the Admiralty. The wreck in the strait was Äpplet, Jakobsson's corrected twin, no longer a rumor in the archives, but a hull with a date and a name. But the confirmation of identity brought a new, uncomfortable question. If this ship was the corrected version, built with the same high-quality materials and engineered with the stability lessons learned from the Vasa, why was it lying in a scuttlefield? The wood proved it was the sister. The location proved it was discarded. The Vasa sank because it was a failure of physics. The Äpplet survived the physics, only to fall victim to a different kind of obsolescence. The laboratory results solved the mystery of the name, but they opened the mystery of the career. The sinking of the Vasa in 1628 was not just a tragedy, it was an industrial emergency. In the shipyard, the sister vessel was already taking shape on the stocks. The hull frames were erected when the planking was underway. The master shipwright, Hein Jakobsson, faced a nightmare scenario. He had just watched the flagship capsize in the harbor because it was too narrow to support its heavy guns. Now he had to finish the twin without repeating the catastrophe. He could not scrap the investment. He had to engineer a solution on a ship that was already half built. The decision he made was blunt and effective. He ordered the ship to be widened. The beam was increased by approximately 4 feet compared to the Vasa. In the world of wooden shipbuilding, adding 4 feet to the width of a capital ship is a massive structural deviation. It requires changing the curve of every frame and the length of every deck beam. It was a panic modification executed with the timber that was already cut and seasoned in the yard. The result was a hull that looked like the Vasa, but sat heavier in the water. That heavier hull still carried the inward curve the divers had seen on the wreck, tumble home, the sides drawing in as they rose. Jakobsson kept it and widened the foundation beneath it. The Vasa had tumble home, but her waterline was too narrow to support the weight above it. For the Äpplet, Jakobsson kept the tumble home but expanded the foundation. The wider underwater hull provided the buoyancy needed to fight the roll. When the sister ship launched in 1629, and she stayed afloat, and the wider hull likely improved her initial stability. But building a heavy, multi-decked warship on that scale was still a difficult experiment, and the design challenges did not simply vanish overnight. But in trading instability for safety, the builders likely paid a price in performance. Extra width and heavy construction can mean more drag and less agility. Contemporary paperwork and later assessments suggest she was expensive to keep in fighting trim, and she may have spent long stretches on routine duties or simply at anchor, rather than becoming the fleet's celebrated favorite. The irony of the engineering fix was bitter. The Vasa was a fast, beautiful failure that killed her crew. The Äpplet was a safer, heavier answer, one that never became a legend in the same way. For the next 3 decades, the ship slipped into operational limbo. She remained too valuable to abandon, but every season demanded more work, more caulking, more replacement planks, more men and money to keep her credible on the list. The crisis shifted from stability to solvency, and the ledger began to tighten around her. 30 years is an eternity for a warship built of organic material. In the harsh, brackish water of the Baltic Sea, oak does not last forever. It requires constant care, caulking, and replacement of rotting planks. The Vasa is remembered because she died in her infancy, a pristine time capsule of 1628. As her sister, the Äpplet, suffered the slow, unglamorous death of old age. For 3 decades, she sat at anchor or sailed on convoy duties that were critical but forgotten. She was the workhorse that never led the charge. She was the heavy, reliable platform that the admirals used when they had no other choice. By 1658, the geopolitical map of Northern Europe had changed. Sweden was a great power, embroiled in wars that demanded a modern, efficient fleet. The Äpplet was a relic of a previous generation, wide, costly to maintain, and increasingly hard to justify. The Admiralty ordered a survey of the fleet. When the inspectors climbed down into the hold of the Äpplet, they did not see a legend. They saw a liability, aging timber, corroding fastenings, and a refit bill that no longer made sense beside newer construction. The decision was economic. The sister ship was declared unfit for service. This moment in a ship's life is governed by the concept of provenance. In the art world, provenance is the documentation that proves the history and value of an object. In the Navy, it is the paper trail that determines whether a hull is a weapon or a waste product. The provenance of the Äpplet showed a history of mediocre sailing and high repair bills. The ledger did not justify the investment. The Crown decided to strip the asset. The valuable bronze guns, worth more than the ship itself, were hoisted out of the ports. The rigging, the sails, and the furniture were removed. The Äpplet was reduced to a bare skeleton of oak and iron. But a 64-gun ship does not simply disappear. The hull was still a massive physical object that had to be disposed of. Breaking it up for firewood was labor-intensive and low value. The Navy had a more pragmatic use for a retired giant. They needed to seal the shipping lanes leading to Stockholm. The enemies of Sweden were growing stronger, and the deep channel at Vaxholm was a vulnerability. The king needed a wall. The engineers calculated the draft of the Äpplet. If they filled her hold with stones, she would sink deep enough to block the passage of enemy warships, but shallow enough to tear the bottom out of any vessel that tried to cross her. The sister ship was to be transformed from a mobile fortress into a static obstruction. The order was signed in 1659. As the Äpplet was towed out of the harbor for the last time, she was not sailing to glory, she was sailing to her grave. The operation was cold and industrial. There was no ceremony. The ship that had been built to redeem the honor of the Vasa was positioned carefully in the strait. The crew loaded the ballast. They opened the seacocks or cut holes in the waterline. The water rushed into the wide, stable hull that Hein Jakobsen had designed to stay afloat at all costs. The physics finally won. When the buoyancy failed, the Äpplet settled onto the bottom of the Vaxholm Strait, joining the silent ranks of the underwater barrier. The climax of her life was not a battle, but a burial. Vaxholm is the pinch point, the narrow throat any hostile fleet would have to pass to reach Stockholm. In 1659, the Admiralty didn't just retire a ship, they turned a hull into a weapon in the channel. In Swedish terms, it was a blockship. A blockship is defense by subtraction. You sacrifice a hull to steal depth from the waterway. The wreck doesn't stop the sea, it makes the safe corridor so shallow that an attacker risks ripping its belly open and freezing the assault in place under shore batteries. It is a wall you can't see until you hit it. The Äpplet was one of the keystones in that submerged barrier. While the Vasa was lifted in 1961 and turned into a museum icon, her sister stayed where she had been ordered to die, silent, buried, and useful. Once the archaeologists confirmed her identity in 2021, the next question was inevitable. Would anyone try to bring her up? When the archaeologists confirmed the identity of the Äpplet in 2021, the question of salvage immediately arose. The world wanted to see the sister ship, but the era of heroic recovery has passed. Raising a 17th century warship is a logistical and chemical nightmare. The wood of the Vasa must be sprayed constantly with polyethylene glycol to prevent it from turning to dust. It is a preservation battle that never ends. For the Äpplet, the priority is to study and preserve her in place. There is no public plan to raise a 17th century warship from this channel, and any attempt to do so would risk destroying the wreck's context. The brackish water of the Baltic is one of the world's most favorable environments for preserving wooden wrecks. It is cold, dark, and low in oxygen, slowing the biological consumption of the timber. The heavy stones that were loaded into her hold in 1659 are now part of her structure, pinning her to the seabed. To lift the ship would be to destroy the context of her final mission. She is not just a ship, she is a piece of the defensive architecture of Sweden. Instead of a physical lift, the salvage of the Äpplet is largely digital. The team used high-resolution photogrammetry to document the wreck and build a three-dimensional model that can bring the ship to the public without tearing her from the seabed. This is the new frontier of marine archaeology. We do not need to drag the past to the surface to understand it. We can visit the wreck on its own terms. The legacy of the Äpplet is no longer defined by her obscurity, or she is the completed half of the story. The Vasa shows us the ambition and the hubris of the empire. the failure of physics in the pursuit of glory. The Äpplet shows us the correction, the pragmatic reality of naval power, and the ultimate sacrifice of the machine for the safety of the state. One sister stands in the light, a monument to a disaster. The other lies in the deep, a silent guardian of the strait. The barrier at Vaxholm is still there, and at the center of it, the heavy, widened hull of the Äpplet holds the line.